All right, let's talk about that phone in your pocket. We're going to dive into the one single, absolutely brilliant idea that makes the whole thing possible. And to do that, we have to go right back to the beginning. So it all starts with a question that you've probably never even thought to ask. Why in the world do we call it a cellular phone? I mean, it doesn't look like a cell, right? It's not biological. Well, the answer to that really simple question, it unlocks one of the cleverest engineering solutions of the entire 20th century. But before we get to the genius solution, you gotta understand the problem they were facing. See, before cellular came along, wireless communication was basically hitting a brick wall. There was this huge, invisible traffic jam building up in the airways, and nobody had a clue how to fix it. Yeah, the old way of thinking, it was all about brute force. You just build one massive, super high-powered tower and have it blast a signal across an entire city. Kind of like one single giant radio station trying to serve every single person. The problem? You run out of space, fast. Only a handful of people could talk at the same time, and the interference was just awful. And this right here, this shows you the big shift in thinking perfectly. On the left, that's the old way. One giant cell with one tower basically screaming as loud as it can, creating a total chaotic mess. But on the right, that's the new idea. What if we break that huge area into a bunch of small, manageable little cells, each with its own quiet, low-power tower? It's literally the difference between shouting and having a network of organized whispers. So this new approach, they called it the cellular concept. And let me tell you, it wasn't just some small improvement. No, this was a total game changer. It completely rewrote the rules for how to share the most precious and limited resource they had, the radio spectrum. Okay, so how does it actually work? Well, it really boils down to 3 key steps. First, you split the cells. You just chop up a big city into a honeycomb pattern of smaller areas. Those are your cells. Second, and this is the truly genius part, is frequency reuse. You can use the exact same radio channel in different cells. You just have to make sure they aren't right next to each other. Think of it like this. 2 different towns can both have a main street, right? Because they're far enough apart that no one gets confused. And finally, the handoff. This is the magic that passes your call from one tower to the next when you're driving down the highway and you don't notice a thing. So here's the kicker. By thinking small, the system got way, way more powerful. All of a sudden, you could have thousands, even millions of people making calls at the same time instead of just a dozen. That citywide interference problem? Gone. Now it was just a tiny, manageable issue between neighboring cells. It was just an unbelievably efficient way to use the airwaves. All right, so you've got this amazing theory, right? So what do? You build it. And that's exactly what they did. The very first attempt was called 1G, for first generation. This was the cellular concept being put to the test in the real world. And like any first draft, it was full of incredible promise and, oh yeah, full of huge problems. So what exactly was 1G? Well, at its heart, it was completely analog. Your voice was basically turned into a radio wave, just like the music on your car's FM radio. Now, at the time, this was absolutely groundbreaking. But as we're about to see, that analog foundation, it was also its fatal flaw. And boy, as soon as people started getting their hands on those giant car phones and those iconic brick phones, the cracks in that analog system didn't just start to show, they became massive canyons. And it all happened really, really fast. This really lays it all out, doesn't it? On one hand, you had demand from people just skyrocketing. Everybody wanted one. And on the other hand, the 1G network just couldn't handle it. The capacity was tiny, the quality was terrible, and the security was a joke. The whole system was basically doomed from the start because it just couldn't scale. Now, what's super interesting here, and kind of counterintuitive, is that the biggest problem wasn't a weak signal. The towers had plenty of power. No. The real killer was interference. Because everything was analog, the signals from all the different cells would just bleed into each other and create this horrible mess of static and noise that would just drown out your call. So what did that mean for you, the person just trying to make a call? It meant total frustration. I mean, the source material says it all. Unstable voice quality, plagued by signal drops, shadowing, and multipath fading. In plain English, that means your call could sound like you were underwater one second, and then just poof, gone the next. Oh, and if that wasn't bad enough, the security, wow, it was basically non-existent, a total nightmare. Since the signal was just an open analog radio wave, there was zero encryption. Anybody with a simple radio scanner could just listen to your conversations. And even worse, criminals figured out how to capture your phone's signal and clone it onto another phone, running up thousands of dollars in fraudulent calls on your bill. But honestly, the final nail in the coffin, the biggest failure of all, was this. The system failed to deliver on its most basic promise, mobility. Remember that magical handoff we talked about? Well, in the 1G analog world, it was slow, it was clumsy, and it barely worked. Driving from one cell to the next almost guaranteed your call was going to drop. So yeah, the system was cellular, but it wasn't really mobile. But here's the thing. The spectacular failure of 1G wasn't the end of the story. In fact, you could argue it was the best thing that could have happened. It was the most important lesson the industry could have possibly learned, and it pointed the way forward with perfect clarity. So, what were the big takeaways? What did they learn from this whole mess? Number one, analog systems cannot scale for massive demand. It's impossible. Number two, that radio spectrum is incredibly precious. You have to use every last bit of it efficiently. Three, interference isn't just background noise, it is the number one enemy, and you have to fight it constantly. And finally, security isn't something you can just add on later. It has to be baked in from the very beginning. And it turned out the answer to every single one of these problems, every single one, was to go digital. Where analog was noisy and full of static, digital signals were crystal clear. Where analog was inefficient, digital could use compression to squeeze way more calls into the same tiny space. And where analog was wide open and insecure, digital made powerful encryption possible, finally making your calls private. And just like that, it was over. The great analog experiment had worked. It proved the cellular idea was sound, but it also proved without a doubt that analog technology could never ever deliver on that promise. The lesson was crystal clear. Analog had hit its absolute limit. Which, of course, leaves us with one big, fascinating question. If analog was the problem that needed to be solved, then how exactly did the digital revolution of 2G take all these tough lessons and use them to build the world we know today?